Thank you so much everyone for coming here today. This is FWM315, which is Create Real-Time Event-Driven Applications with Amazon EventBridge and AWS AppSync. I'm Venugopalan Vasudevan. I'm a Senior Specialist Solutions Architect with AWS Frontend and Mobile team. Let's get started. So this is the agenda for today. So we will briefly cover what is GraphQL and what is the overview of GraphQL and what is AWS AppSync, and then how AWS AppSync leverages GraphQL to provide that powerful API solutions for you. And we will deep dive into real-time scenarios and how AWS AppSync can be used to deliver these use cases for your customers. Then we will see filtering and invalidation, which are some powerful capabilities when it comes to GraphQL and AppSync. And we will also talk about integration between AppSync and EventBridge and how it can be used in conjunction to deliver these real-time use cases to your customers. And followed up with an exciting demo. And I will take questions at the last, and I will be available after this meeting as well if you have specific discussions that you want to make. With that, we will go into the presentation. Okay, so what is GraphQL, right? GraphQL is a query language for APIs and a runtime to fulfill those queries with your existing data. GraphQL is expressed as a declarative language to fetch data from your backends, right? So GraphQL is expressed in a schema file with types and fields and operations. So as you can see from this picture, so there is a type called project, which is a container of fields, and you have a lot of fields like name, tagline, contributors with data types. And the clients exactly know what they are asking for. In this case, they are asking for tagline from a type project with a name input as GraphQL. And they are always getting predictable results because it is very strongly typed system. And with respect to operations, so operations supported by GraphQL are queries, mutations, and subscriptions. Queries are used for reading the data. Mutations are using for writing the data. It could be create or update or delete. Subscriptions are basically a client subscribes to data changes from a mutation. And what is the best way of running a GraphQL workload on AWS? You can run your own GraphQL server on AWS, but no one wants to manage their own servers right now. So AppSync provides that serverless, fully managed solution for running your GraphQL workloads on AWS. It provides the robust and scalable solution where it provides real-time capabilities and offline capabilities as well to have this real-time enabled for your users. And a question I always get asked from a lot of customers is, does GraphQL replace REST services? Not necessarily, right? It can coexist in your same stack. Even I've seen a lot of customers use a GraphQL engine on top of REST services to consolidate data and provide a single pane of view for their end users. So what are some advantages of using AppSync, right? First one, simplified data access. It provides the consolidated view from all data sources. You can even connect to other REST services, data sources, databases, get data, and then give it back to your client. The second thing, improve application performance. You're fetching only the data which is required, not overfetching or not underfetching, which means that lesser network requests, lesser network hops to fetch the data for a particular view. In REST services, the client has to manage multiple endpoints, go to multiple REST services to get the data, consolidate on their client end, and provide to end users. But in GraphQL, all that heavy lifting is done by AppSync for you. And build applications faster. The client exactly know what they are fetching and what they are receiving, which means that they have total control over the data, thus making application development faster. And we will talk about real-time experiences in the future slides. All right, so how does AppSync work, right? So it can natively connect it to polyglot data sources, meaning it can connect to a NoSQL data store like DynamoDB. It could connect to a SQL data store like Aurora. It can connect to Amazon OpenSearch service. For any other services in your account, you could always use Lambda functions. And for connecting to other REST services, you could use HTTP endpoints. And local data sources are, you can think that as a PubSub where data is not persisted. Okay, so let's take an example. So the thing you see on the middle is a schema file. This is an e-commerce example. where the profile information is fetched from a NoSQL data store, which is a DynamoDB. The order information here is fetched from a Amazon API gateway. It could be a REST service. The pricing information is fetched from Amazon Aurora, again, which is a SQL data store. And the in-stock information is a calculated field from a Lambda function after applying some business logic, which means that it can go across these data sources, go across these REST services, consolidate the data for you, and then give it back to your client. The client has to worry about only one single endpoint, which is the GraphQL endpoint. Okay. Okay, so what are some main components of AppSync? So we talked about schema file, we talked about data sources. Now comes the business logic. So that is the resolver layer. Resolver is basically a mapping between your schema file and your data source. So what in the schema file matches to what data source, right? So currently we support 2 languages to create these resolvers. Initially we have been supporting Apache VTL, which is velocity templates. Now last 2 weeks back we introduced JavaScript resolvers, where you can write your resolver logic in your favorite JavaScript language. All right, what about security, right? So AppSync allows multiple security methods to protect your endpoint. It could be an API key for a non-production environment or a test environment. If you are using highly scalable user pool, you could always use Amazon Cognito. And if you are using OpenID Connect provider, that is supported too. And for service-to-service communication, you can use AWS IAM. If you have your own custom authorization logic or any mechanism that your company owns, you could always use Lambda to connect to that and verify these claims. All right. What are customers building with AppSync? There are 3 main use cases that we have seen customers build with AppSync. First one is universal APIs, meaning for consolidation of enterprise data. So basically go against all these data sources, consolidate a single view, and then provide it to their end users. The second thing is real-time application. Real-time application enable that interactive collaborative experience to your customers. Chat functionality, fan engagement, location-aware notifications, etc. Okay, then comes the offline application. If you have users go in and out of network, right? AppSync can be used to build these offline applications like field service apps or IoT apps, etc. Okay. Okay, let's now focus on real time, right? So what is exactly real time? Okay, so here there are 2 sides of the coin. One is publishing the data. Somebody like a user or an event or a backend publishes the data, and somebody is receiving the data, like a subscriber or a client application is receiving this data. It could be your mobile device or it could be any other web application receiving that data for a particular selection set. So the information is delivered to the client as it happens, and we are talking about a push mechanism here, not a poll. We are talking about, again, milliseconds response time and not seconds. Could be one-to-one or one-to-many or many-to-many as well. A backend service broadcasting data to multiple clients. Okay, what are some of the use cases, right? So let's talk about few use cases in this list. First one is live sports score as the game happens, right? And stock quote updates for your portfolio. Connected homes to send information to connected devices. Geolocation tracking like package delivery. Whenever a package arrives near your house, you get a notification. E-learning mechanism like virtual whiteboarding or coding exercises that you can enable with your customers. Social media interaction like chat or fan engagement, etc. To name a few, these are some of the example use cases. We'll talk about few use cases in detail now, right? So this shows an application architecture for an e-commerce quick pickup use case, where AppSync is used here to deliver messages to store employees whenever a user is near your store. So assume you're driving to the store and the employee gets notified that, hey, you're coming near the store, so that they make sure that the item is ready for a quick pickup for better customer experience. So here Amazon location service is used to track users' information or where the user device is, send that to Amazon EventBridge, and Amazon EventBridge again sends that to AppSync through a mutation, and AppSync again gives that to an Amplify UI where the retail store employees are connected. Let's talk about another example where this is in media and entertainment industry to deliver real-time sports updates. Right, real-time is really important for that engaging, interactive experience in the media industry. So here, AppSync is used to get the real-time sports score updates or fantasy league updates for your favorite gamers, and also fan engagement. You can engage with your fans using this architecture. Okay, let's talk about another architecture. This is a chat application which is hosted in AWS Amplify, and AWS AppSync is able to provide that real-time notification whenever somebody joins a room or whenever somebody starts typing, the other people in the room gets a notification, right? So this is again another example where AppSync is used for that real-time use case. Okay, how does this all work together? How does AppSync delivers real-time to your customers? So AppSync takes advantage of the GraphQL subscription to provide that real-time operation by pushing data to connected clients. So you can have one or millions of connected clients for listening for any mutation, so that you can make any data source which is natively supported by AppSync real-time. So in this case, multiple data sources are connected. Assume a client is issuing a subscription operation. Whenever a client invokes a subscription operation, a secure WebSocket connection is opened and maintained by AppSync, so that it is connected throughout the process, so that whenever a data changes with respect to a mutation, it is getting delivered to the client. It is established and maintained for 24 hours, and then you need to reconnect the subscription to get another messages. All right, so let's take an example here. So assume you have 6 authorized clients here connected to a subscription operation through secure WebSocket channel. You have a AppSync API which is connected to a Amazon DynamoDB data source. Again, I'm showing only Amazon DynamoDB as an example, but it could be applicable for any natively connected data source. Assume one of the client is issuing a mutation where other clients are interested in that data. So what AWS AppSync does is, it basically gets that mutation and performs authorization checks and performs any resolver business logic, and then applies that mutation to your data source. In this case, it's a DynamoDB table. Once the data is persisted, then AppSync broadcasts that data to connected clients, whoever is interested in. Here, the selection set, meaning each client can have their own data. For example, one client can say, hey, I need only ID and title. The other client can say, I need all the data. So the selection set, meaning the fields that are requested by the client, can vary. All right, let's take an example. What if another service like SNS or SQS or EventBridge or IoT wants to update a mutation so that it needs to be delivered to connected clients? There you can use a Lambda, where Lambda issues a mutation to AppSync, and AppSync again performs that authorization resolver logic checks, and then gets to the Amazon DynamoDB data source. Once it is persisted, it is again sent to connected clients. Here in this case, since it is a service-to-service communication between Lambda and AppSync, it's delivered through or authorized through IAM credentials. Let's take another example. What if there is another process or an out-of-band request which is updating the DynamoDB table? In last 2 examples, you saw a mutation is required for AppSync to recognize that something has changed in the database so that it can deliver the data to the clients. But in this case, AppSync is not aware of the mutation, but still you have a requirement for getting the data to the clients. How it can be achieved? In this case, what we are going to do is, we are going to do a DynamoDB stream of the data and then invoke a Lambda function out of the DynamoDB stream, and that Lambda function will issue a mutation. Here in this case, the out of the band request has already updated the data source, so you don't have to persist the data again. So that's where you use local resolvers, where you don't have to persist the data. Still, you're going to deliver the data back to your connected clients. All right. So wrapping up the real time with AppSync, the connection management, the scalability, fan out, broadcasting, everything is managed for you by AppSync. You don't have to manage any pub sub server, no connection management, no servers to worry about. And the metrics like connected clients, active subscription, message size, status, error, all those things are delivered to CloudWatch automatically. And how do I get started? Like, that's the next question. So you can get started with a generic PubSub API, which is given in the AWS console, or with a CDK, and then expand your use case. Again, without having any GraphQL knowledge, you can straight away get started with that API. All right, let's talk about filtering and invalidation capabilities when it comes to AppSync. So what is basically filtering, right? So filtering, in the sense, there are two aspects to filtering. One, only certain clients needs to receive that data, not all the clients. The other scenarios is client can dictate saying that I'm only interested in certain part of the data or certain data which is matching a condition. How do I get that? That's where filtering comes into picture. In this picture, you see that only 3 clients receive the data from AWS AppSync, right? There are scenarios where only one client needs to receive the data. In a chat scenario where conversations are very private, you want to deliver messages only to a single client or a single application or a single user, that's when filtering can be used as well. Again, 2 types of filtering which is supported in AppSync. First one is basic filtering. This is client initiated, which means it is up to 5 arguments defined on the client side. For example, client can say, hey, give me the data when order ID matches or equal to 1, 2, 3, 4. That's a typical example where client can initiate that filtering logic from their side. It's again AND logic only, no operators, strict equality. This is very limited in their functionality. That's why we introduced enhanced filtering this year. So where multiple logical operators like AND, OR, contains, lesser than, greater than, in, between is supported. It is defined centrally in the resolver, meaning AWS AppSync API handles it. And you can also specify dynamically these filters from the client, which is evaluated at the resolver side. Again, it is specified in a JSON format. And there is also a special feature called invalidation, where what if you want to disconnect a WebSocket connection from a connected client? In that case, you can specify an invalidation filter in your logic to invalidate that WebSocket connection as well. These are some examples of filtering logic. Take an example of ticket management system, right? So here, only tickets are delivered to clients matching those conditions. So for example, a severity greater than or equal to 7 and high or medium priority. Or if the classification is security and member of the group is admin or operators, then only deliver these tickets, right? So that's how you specify a ticket in your resolver logic. Again, any field in the GraphQL schema can be used as a filter. Another example where chat applications, where you are going to deliver messages only to the client users, where they belong to organization org1, channel where they belong to channel 1 or channel 2 or room 1 or room 2, and the username is a valid logged in user. Then only deliver these messages. This is another example of dynamic client filtering, where client initiated filtering. This is an example where fantasy league update scenario, where client is requesting, hey, I am interested in the scores when the player name matches one of these values. Again, as I said earlier, filtering is really important because it could be client initiated, it could be server initiated, to make sure that only the right data or the right client receives that information. All right, let's talk about invalidation, right? So what is invalidation? So there are scenarios where you need to disconnect a WebSocket connection from the client. So this is typically used in authorization scenarios where you want to block a user from chat application or remove a user from using that WebSocket subscription. This is used in those scenarios. Again, the filter needs to be specified in the resolver logic, saying that this is my invalidation filter, and a special mutation needs to be invoked to execute that filter. So let's see that. So this special mutation is basically an administrative operation. Make sure that only authorized user can execute that mutation. If the payload in that mutation matches a filter, right? I'm going to show an example in a couple of slides. If it matches the filter, then the invalidation occurs. Another great example here is assume you have a real life sports event which is happening where millions of clients are connected. So once the game is over, you need to disconnect all the clients for cost efficiency and performance purposes. So in that case, AppSync API can initiate this filtering logic or initiate this mutation to disconnect all the WebSocket clients. So again, in this example, a mutation is occurring where it matches the filter and the connection is dropped. Okay. This is a chat application example where on the left side you see invalidation filter where the filter name is username equal to a valid logged in user, and you are issuing a mutation which is a delete conversation user, and the payload matches the username, the exact filter. So once you issue this mutation, the WebSocket connection is disconnected. All right. Okay, let's talk about EventBridge integration now. Okay, so quick 101 on EventBridge. EventBridge is used in event-driven application, which is an event bus, which is very scalable, again pay-as-you-go model, and to choreograph operations between two systems or two different data domains. It can connect any two systems with rich set of configuration and rules. On the left, what you see is the event producers. It could be an AWS service, it could be your own application with custom events, or it could be SaaS apps like a partner event source. And Amazon EventBridge applies rules on top of these messages with some filters, then delivers to targets. The target could be, again, any AWS service, or it could be an API, or it could be a webhook also. So there is a special feature called API destination where you can call APIs within as a target in EventBridge, and with some authorization rule, of course, to deliver these messages. Okay. Again, when you combine the power of EventBridge, which is event-driven and connect loosely coupled systems, and with AppSync, which is real-time and connect to millions of clients, you are unleashing the possibility of making any system real-time and also event-driven. All right. So in this case, the integration between EventBridge and AppSync is going to take place through API destination, meaning any valid producer of message could issue a message to EventBridge, and it could be converted to a mutation to AppSync. You're basically posting a call or a mutation call to AppSync, and all the connected clients through WebSocket capability are going to receive that message. All right, some notes here or some highlights on this integration, right? Again, number one, the producers on consumers are loosely coupled. We are essentially, what we are doing is choreographing operations across systems or domains and adding a real-time capability without having GraphQL knowledge, connect any two disparate systems together. Again, publishing out-of-band requests that we talked about that can be enabled through this integration, deliver to multiple targets. Meaning one target could be AppSync and the other target could be you're updating another administrative system through SNS or SQS, etc. That is also possible. Again, rich set of rules and filtering capabilities. What I mean by filtering capabilities is you can filter based on some message conditions in EventBridge and apply transformations as well on EventBridge. Again, we are going to use API destination to trigger an AWS AppSync update. Data persistence is optional. Meaning if you trigger a mutation to AppSync, you could either choose to use a local resolver or a DynamoDB or any other data source resolver if you want to persist data or not to persist data based on your use case. All right. Okay, so what are some use cases, right? So first one, order fulfillment system, where order is getting fulfilled or shipped in one of the system, and the customer who is having a mobile phone in another system, receives that message saying that, hey, your order is fulfilled. Incident response system, again, production event is happening in one system. that somehow get translated and gets to your laptop or your web application that you're listening to. Location tracking system, again, package delivery, right? So your package is getting delivered, which is getting updated in one system, and you are listening for that via your mobile device or IoT device saying that, hey, a package is left on your front door, right? Again, IoT devices, you can choreograph actions between IoT devices using this mechanism where, hey, for example, turn on my Christmas lights at 7 p.m. every day. Again, partner events like SaaS application, which is happening in one system or SaaS systems, and then you are getting a notification in your system. So these are some examples. Again, it could be one-to-one, one-to-many as well. Okay, so let's again take an example here. So the AWS service is trying to issue a mutation or trying to send a message to AWS EventBridge, and a mutation is happening to AppSync, and assume you have like 6 different clients which are connected to secure WebSocket channel. Assume one of the clients is receiving a message here based on some filter conditions, and it could be one-to-one as you see in this picture, or one-to-many as well, like you see in this picture. So again, in short, with this EventBridge integration, again, you are connecting 2 disparate systems. Any message or any notification that you want to send to AppSync or connected clients, you could do with these integration. Okay, so what are some SaaS app integration, right? So these are some list of partners. Again, this is not a complete list. To review our complete list, you can always refer our documentation. For example, all these SaaS app integration could happen. These events could be sent to EventBridge, and EventBridge could deliver that to AppSync and to your connected clients as well. All right. Okay, let's see a demo. Right. So whatever discussed so far, we'll see it in action. Okay. All right. So let's see this. So this is a serverless to-do list application which is hosted in AWS Amplify, and AppSync is used as a backend layer, and we have DynamoDB as the data source. So we are going to see first the mutation, how the client is connected and how a subscription happens, how the client receives the data as part of the mutation, and second thing, we will also see EventBridge integration, sending a message from EventBridge and giving back to the client. And we will also see, AWS service, another AWS service updating this data source as well. All right. Okay. First, again, let me create some to-dos here. See how that works. Okay. Let's add a to-do, second to-do as well. So once I create a to-do here, the UI is listening for the subscription and updating the UI with the latest information of to-dos. So I'm updating this, I'm removing this, etc. So let's look at the architecture, right? So I have AWS Amplify application hosting this UI, AppSync as the API layer, and I have DynamoDB as the data source, and Lambda function as the another data source. We will see about the other components later in the demo. Okay, let's go back to the AppSync console. So I have this schema file here where a simple to-do type and mutations, as you can see, create to-do, update to-do, delete to-do, and I also have a subscription on create to-do. So meaning whenever a to-do is created, I'm subscribing to that data. Okay, let's go to the client application to see how it is structured. My client application is a React.js application hosted in Amplify. So I have something called subscription.js where I am defining my subscription and selection set, what fields I'm expecting from the subscription. And then in app.js, which is the main file for React application, I'm issuing that subscription and waiting for the data to get back to me, the list of to-dos when it is created. Okay. Okay, let's go back to the console again. Okay, I have two windows here. On the left, let me issue a subscription, and on the right window, I'm going to issue a mutation. See how the data is coming after the mutation to the subscribe client. So I issued a subscription here called on create to do with this selection set or the list of fields that I needed. I'm issuing a mutation here. Mutation is like creating a data. Okay. There you see the subscription data is coming back to the client, which is on the left window. Let's do it one more time, another mutation. Right? Second mutation. Okay, so now you see we get one more subscription data for the left side client. I'm going to stop the subscription now. Let's see how the filtering is used in action. Okay, let's go back to the schema file. And I have another subscription called on create to do completed only, which is listening only for completed to dos based on certain filter conditions. So my client is only interested in completed to dos. So here is the resolver logic where I'm defining this filter. So as you see here, the filter is if field name is completed equal to true, then only give me that data. That's what I'm describing in my filter. Okay, let's issue another query in the left window on the new subscription and execute a mutation to see what's happening. Okay. Okay, I'm executing the second subscription, which is completed to dos. It's running on the left window. On the right window, I'm executing a mutation, the same mutation. But my client does not receive the data because the completed is false here. So let's make it true and issue another mutation. Change the title and then issue true. Okay, I am executing another mutation here. There you see, if the completed is true, then only I am receiving this data. Basically, I am filtering out all the data where completed is false. Right. So let's see the upload handwritten to do where another AWS service issues this mutation. Again, this is the application architecture where I have AWS AppSync, another Lambda data source which is uploading a handwritten to do to Amazon S3, which in turn triggers a Amazon EventBridge rules, which in turn triggers a target Lambda function, which starts a Amazon text track job, which extracts the to-dos from handwriting. And then once it is completed, it issues a notification to SNS, then triggers another Lambda function. And that Lambda function is the service which is going to issue a mutation to my AppSync. And my AppSync again delivers that to my UI. And this is a handwritten to-do from my daughter, like finishing math homework, reading book for 15 minutes, etc. Let's see how that works in action. Okay, so I'm uploading the data. Okay, so the file is uploaded successfully. Might take a couple of seconds to get it in the UI because we have a lot of components involved. Okay, so there you go. So TextRact has finished the job and Lambda has issued a mutation and my client receives all the data which is from the handwritten to do. Okay, finally let's see how the EventBridge integration works. Okay, so I have an event bus called default and to-dos. So let's use default and I have a rule here called to-dos, where if the event pattern matches source is EB and detail type is create to do, then hey, trigger this target for me. And the target you see is an API destination, which is my GraphQL endpoint. Again, I'm going to use a post method to create this mutation. and API key. I used API key for simplicity purposes. Okay, let's send a test message, see how that whole flow works. All right, so this is an input transformer where I'm going to, if I send a test message, I'm going to transform this message into a AppSync understandable mutation. So this is basically if you use a curl command to update a AppSync API, it's going to work the similar way. I'm going to extract few things from my input, create a mutation which is understandable by AppSync. All right, again, now let's send a test message, send event. Again, event source is EB. Detail type is create to do. And event detail would be the data required to create this mutation. Again, my title is event from EventBridge. All right, so yeah, so the message is a success, and there you see the event is coming from EventBridge, which updated the UI. Okay, so that's it with respect to demo, but as I said earlier, when you combine the power of EventBridge and AppSync, you're unleashing the possibility of making any system real time, which means that any source which you see in the EventBridge could be made real time, and you can deliver that to any client. Again, AppSync makes it very easier to get started with the WebSocket capability, so you can deliver these real-time events or notifications to your customers. Could be one or millions of connected clients because of the scalability. All right, yeah, that's it with respect to my presentation. Again, thank you so much for listening to me today. Again, I'm Venu Vasudevan. I'm a Senior Specialist Solutions Architect. You can connect to me with this email, or you can scan this barcode for getting started with AppSync. And again, feel free to complete the session survey. And after this, I'll be available for any questions you have, and we can always discuss. Thank you again.